Welcome to this video on classification trees in data mining. Today, we will explore how these powerful tools help us make predictions and segment data. Let's begin by discussing the outline of what we will cover. First, we will understand the strengths and limitations of classification trees. Next, we will learn about the steps of the CART algorithm for building these trees. We will also see how classification trees are applied for predictive tasks. Then, we will evaluate their performance and complexity. Finally, we will implement classification trees using Python's scikit-learn library. Classification trees are tools that partition feature space into distinct regions. Each region is assigned a majority class, allowing predictions for categorical values. They are ideal for tasks like customer segmentation and object categorization, making them highly practical. Let's look at the advantages and disadvantages of classification trees. They are easy to interpret and do not require feature scaling. Additionally, they are quick at making predictions. However, they struggle to extrapolate and perform poorly with small datasets. They may also have longer training times compared to simpler models. Now, let's explore the steps of the CART algorithm. This systematic process begins by selecting a feature for splitting the data. It then identifies a threshold to divide the feature space. The algorithm computes the Gini index for each potential split and evaluates all features and thresholds. It chooses the split with the lowest Gini index and repeats this process until a stopping criterion, like minimum leaf size, is met. This ensures effective and interpretable results. When implementing classification trees in Python, scikit-learn simplifies the process. The provided code snippet initializes and trains a decision tree classifier using training data. It then evaluates model accuracy by comparing predictions to test data. This approach makes building and assessing classification trees straightforward. Evaluating performance and complexity is crucial for classification trees. Key metrics include accuracy, precision, recall, and F1 score. Tree complexity, such as depth and number of nodes, impacts interpretability and overfitting risk. To avoid overfitting, techniques like pruning or depth constraints are necessary. Balancing these factors ensures a reliable model. To summarize, classification trees are intuitive and powerful tools in data mining. The CART algorithm enables optimal splits, ensuring effective predictions. Python's scikit-learn library makes implementation simple and accessible. Balancing complexity and performance is vital for achieving the best results. Thanks for watching. If you enjoyed this video, please like, share, and subscribe for more content on data science and technology. See you next time.